Hey guys, I'm here talking about Project 8, Homework 16. Alright, so let's get right into it and let's go talking about it. So, the question states it's for Theorem 5 if ABCD is a parallelogram and the diagonals meet perpendicular, then ABCD is a rhombus, right? So, in this question, they ask you to please mention the givens, please mention the shows, and please mention the diagram. So I already put the diagram here, so that's already done. The next slide I'll mention given shows, all right? So show given ABCD is a parallelogram and it meets perpendicularly. So let's take a moment to think about that. Like, well, since ABCD is perpendicular, that means line AB has to be perpendicular to line DC because those two lines are perpendicular. Same thing also applies here. Same thing also applies to the sides, right? AD equals to BC, right? Because those sides are parallelogram. So that's the theorem also parallelogram because those two sides, right? The tops are equal to each other as well as the sides are equal to each other, but neither are equal. And then you have to show A, B, C, D is a rhombus, right? And for the theorem rhombus, right? I should have mentioned this. So definition for rhombus is that all those sides are equal to each other. There isn't no difference. They all have to be equal. All of those four sides are equal to each other. All right. So in the diagram as displayed, I drew those two sides. I drew the given. All right. Now also go right into the just statement justification, right? Which ABCD is parallelogram and the diagonal must be perpendicular, which is given. Yeah, that's true. In which I drawn it, it's AB is congruent to DC and AD is congruent to BC. Right. Five. That's the definition of parallelogram. So as I mentioned before, those two sides are parallel to each other. The other two sides are parallel to each other. However, they're not parallel to each other. When it comes to like AB, is it equal? Is it equal to? Is it congruent? My bad. Is it congruent to AD? AD? No, because we don't know. Because it's a parallelogram. However, we're proving is it a rhombus? Let's go right into it now. Because since we have step one, step two, right? Step three, the measurement of angle BAC is equal to the measurement of angle DCA. Take a moment to think about that. Like, why did I mention those two angles? Take a moment, think about that. Moment and think about it. Like, well, spacing interior, ulterior, alternate interior angle theorem. Well, yeah, that makes sense because if we just fully drawn it out, right, based on the diagram, we have right these two angles, right? That angle has to be equal to the other angle on the bottom. So it makes perfect sense there. Yeah. Step four also states, step four states, measure of angle DEC equals the measurement of AEB. How is that? Well, they easily know that's the vertical angle theorem, right? Because since those two angles are vertical, so like, hey, they equal to each other, right? Thus, That's for step 5. We have triangle DEC, right, is equal or congruent to triangle AEB. Take a moment to think about that. Like, well, since we have all those together, what can we say? Well, it's because of the A angle sides that 3, 2, and 1. You probably take a moment and say, wait a minute. Is it? Well, it is because since we have our two angles and then we also have our side. We have a side, right? You probably take a moment and say, wait, could it be another way around for the angle, for one of these angles? Well, yeah, we can say angle, definition of angle ABD is congruent also to angle CDB, because that's also basically a third angle theorem. Since we have those two angles are connected, then hey, wouldn't that make sense also? Yeah. It's gonna be angle side angle. Yeah, that can work too. That can actually float. That floats also, right? But and then also we have for step 6, DE is equal to the line DE is equal to AE, right? Why? Well, it's based on the corresponding triangles, right? Since to prove step 5, right? Step 5 is that theorem that because we know that triangle those two triangles DEC is equal to triangle AEB, right? That makes sense. That makes sense, and thus as we those sides have to be equal to each other, right? Now step 7, that's supposed to be ECB equals to EB. Take a moment to think about that. Why? I guessed it. It's also based on step 5, which is also the corresponding triangles. These corresponding triangles, right? Should I mark this a little bit more, just in case you guys need to say, oh, that makes sense. Now, step 8, AB equals to BC. You're probably like, whoa. You probably jumped the gun too quickly, right? No, we can probably simply prove this very simply, right? Like, moment, think about it. Think about it for a little bit more while than average, right? Moment, think about it. Moment, think about it. Right? Probably stuck right now, so I'm gonna try to take a moment. I thought about it. You ready? I hope you guys are ready, right? Well, step 8, my justification states if bisector of the vector hits the base at its midpoint, then the triangles is isosceles, right? Like, yeah, that makes sense. That makes perfect sense, right? Because since we know those two lines, right? Since we know those two lines, right? Like, wait, these two lines are congruent, right? These two lines. So we have these two lines, right? These two sides, right? So that side equals to this side, right? They have to be isosceles, right? So that means this angle equals to this angle, right? Since we know since we know side AE and side DE, right? They equal to each other. So that means, would that make sense that if these two angles are equal to each other too, right? Using the isosceles theorem, also this rule applies too for line AE, EB, and EC, right? Like, and also since they hit the midpoint, right? Since all four triangles at the midpoint, you're like, wait, that makes sense, right? Because if we just put the vertical, right? Like the vertex, right? Since it has the vertex of the, sorry, right? And since it hit the midpoint, which is the midpoint E, like, so that makes sense, right? Just step 9 makes sense, right? Because since Since we know all sides are equal, that means since we know AE is isosceles and EB and EC is an isosceles, so that means A AB has to equal to BC, right? So because all sides are congruent, right? Because since the theorem explains it, since step 1 through 8, we explained each rule and we broke it down and made it probably a little more complicated, but I hope you guys understand this a little bit more. Like these two sides, like since um since you figure out the isosceles, right? If you figure out the isosceles, right, since these two lines of the isosceles, right, AE and DE are congruent to each other, so these angles have to congruent to each other too. And then so these two angles also have to be congruent to each other too. Because since the isosceles theorem, right? Like, yeah, that makes sense. Perfect sense, right? Hope it does make sense for you guys. And yeah, does ABCD is a rhombus because all sides are congruent. Thus, that's the end of our theorem, right? Let's double check to be sure. Just be sure if you guys don't get lost. ABCD is parallelogram, right? And thus means perpendicular. Thus the line must be perpendicular. Given step 2 is AB is congruent to DC and AD is congruent to BC. Why? Definition of parallelogram. Parallel. Those two sides parallelogram respectively to each other. And then measurement of angle B BAC is equal to B is congruent is equal to measure of angle DCA. Why? Because the arbitrary angle theorem is step 4 you play around this one a little bit more. I recommend this. Measure of angle DEC is equal to measure of angle AEB, right? Because the vertical angle then, but that could be also substituted. I'm gonna put a little comment in the video, which you could substitute this with the another ulterior angle theorem, which is measure of angle ABD is equal to angle CDB. Why? Because of the ulterior angle theorem too. So does however you got to change the theorems around them change around and we like no, you're probably still gonna get the exact same thing, which is just angle, side, right? Or you're probably gonna mix around, which is side, angle, side, angle, but just be double check to see if that theorem makes sense. If it doesn't, then angle, side, right? But in this case, right, triangle DEC is equal to triangle AEB. Why? Because angle, side is based on step 3, 2, and 1, right? Does 6 and 7 respectfully follow step 5. Why? Based on the corresponding triangles, right? Because they correspond triangles. Right, and then for step 8, AB equals to BC. Why? Because if bisectors of the vertex hit vertex angles, hit a base at its midpoint, then the triangles is isosceles. Right? Thus, ABCD is a rhombus. All sides are congruent. Yes. And that's the end of the video. Thank you so much. Have a good day. Have a good night. Have a good evening. And stay safe. All right.